In section 1.5, part 2, we're going to solve linear inequalities. And it's similar to solving the linear equations. There's only one difference you need to remember, and that's every time you multiply or divide by a negative number, you have to inverse or reverse, flip the inequality symbol. And we'll do one of those here in a bit so that you can see why we need to do it in order to make things happen. So the directions are going to ask you to solve each inequality statement, then graph the solution set, and finally write the answer in interval notation. So for example 1, what we're going to solve is 3x minus 1 is less than x plus 3. So the solving process is the same as it's been since you've been solving linear equations. We need to get all the x's on one side. Let's always move the smaller x term. It makes things nicer. So we're going to move this x to the left side. That'll give me 2x minus 1 is less than 3. And because we're isolating x, let's go ahead and move the 1 back across by adding. That's going to give me 2x is less than 4. And finally, we'll divide by 2. And we're dividing by a positive 2, so nothing magical happens here. We just get x is less than 2. So now we've solved it. So then they're going to ask us to graph that solution set. So on a number line, just what we were doing, here's the 2. Again, the inequality says to use an open circle because there's no including the endpoint. We need numbers that are smaller than 2. That's to the left. So there's the picture. And then as our answer, the interval notation would then start over here with the arrow at negative infinity. Going to stop at 2 with a parenthesis. And there you've solved your first linear inequality. Pretty straightforward, not a lot of ugliness here. Example 2 adds in some distribution. On example 2, we have 8 minus 4 times the quantity 2 minus x. That's greater than or equal to a negative 2x. The very first thing we'll do this time is distribute, and that's to eliminate those parentheses. So we're going to distribute in a negative 4. Be very careful. So negative 4 times 2 is a negative 8. Negative 4 times a negative x is a positive 4x, greater than or equal to negative 2x. The 8 minus the 8, that's going to cancel. I'll get 4x greater than or equal to negative 2x. Again, I'm going to move the smaller x term. That would be this one. So I'm going to add 2x back. So I get 6x. And it's okay on the other side just to have the 0. And we'll divide out the 6. And sure enough, 0 divided by 6 is 0. On our number line graph this time, we're going to write our 0. We'll need a closed circle because of that equal to on it. And we need numbers to the right because we want to be bigger than that. Then as our interval, we're going to start at 0 with a bracket. We're going to go off towards infinity. And again, we'll use it. So each one of our examples is going to get a little bit more complicated. It brings in something else that you may not quite feel comfortable with, but trying to give you a broad variety of problems. The next one deals with a fraction. So example 3, we have x over 3. That's greater than 2 plus x over 6. Well, we don't like fractions, and in general, it just works best if we get rid of the fractions. So we're going to multiply everything by the common denominator. So we're going to eliminate fractions. And to do that, we're going to multiply each term by the LCD, the lowest common denominator. Well, in this case, the lowest common denominator between 6 and 3 is 6. So we're going to come in and multiply every single term by 6. So I like to do that by putting parentheses around each term and writing the 6 out in front. I tend to not write the 6 on the right side because that's where I use exponents. So what happens? Well, the 3 goes into the 6 twice. I then have 2 times that x to give me 2x. From the next term, the 6 times the 2, there is no fraction there to cancel. So I take 6 times 2 and get 12. And on the last terms, the 6 cancel completely, and I just get plus x. And now we've cleared the fractions, which are beautiful. Now we don't have to worry about them. Let's go ahead and move the x. That's going to give me x is greater than 12. So once we got rid of the fractions, it was fairly simple to solve the rest of it. Again, we're going to graph it. Here's our 12. Open circle going to the right because we need numbers bigger than 12. So our answer then is going to start at the 12 with the parenthesis. That's because of the open circle, because of the greater than, and heading off towards infinity with the parenthesis. So there's one involving fractions. Okay, our next example is what we call a compound inequality. And a compound inequality, as we said previously, this has more than one inequality statement in it. So instead of having a left side and a right side, we're going to have a left side, a middle side, and a right side. So we have 4 is less than 2x plus 2, which is less than 10. So our goal is to get the x isolated in the middle. And to do that, the very first thing we have to do is move this 2. Now, if I move it from the middle to the right side, I also have to subtract it off the left side. So you have 3 places to move it from. So again, everybody in the room gets the same amount of candy or loses the same amount of candy in this case. So 4 minus 2 is going to give me 2. Now the only thing we have in the middle is a 2x, and that's going to be less than 8. To isolate the 2 in the middle, we'll divide everything by 2 again, the left side and the right side. That's going to give me 1 is less than x is less than 4. And we graphed these a few minutes ago in the previous video. So we know that we're going to go between 1 and 4. Here's my 1, here's my 4. We need an open circle on both, and we're trapped between the 2 because we have to be bigger than 1, but still smaller than 4. So we're going to go from 1 to 4 with parentheses. Nice. Okay, let's do another one. Another compound inequality. This is example 5. What you see here is 0 is less than or equal to 1 minus 1/3 x, which is less than 1. Okay, before I worry about that 1/3 x, I'm going to go ahead and make sure that the x term is the only thing in the middle. So because there's only the one fraction to deal with versus the previous example that had 2 fractions, let's go ahead and move this 1 out of the middle first, trying to make it a most efficient process. So we're going to subtract 1, subtract 1, subtract 1. So it's going to give me -1 is less than or equal to a -1/3 x, which is now less than 0. Again, it's okay when 0 happens. 0 happens. It's an important placeholder for us. Now what we're going to do is we're going to multiply everything by -3 to clear that fraction in the middle. So we're going to take this and multiply it by -3. We're going to take the middle and multiply it by -3. And finally, we're going to take 0 and multiply it by -3. Now I'm purposely going to make a mistake here so I can show you why you have to flip when you multiply by a negative number or divide by a negative number. So the -3 times the -1 gives me a +3. I'm not going to do the flipping, and I know I'm doing it wrong. I just want to illustrate. In the middle, the negatives are going to cancel, and the 3's cancel, giving me just x. On the right side, I'm going to get a 0. -3 times 0 is 0. And when you look at this inequality statement, this is saying that 3 is less than 0. 3 is not less than 0. We know that's wrong. So that's why we're going to come in and instead flip those inequalities, because we multiply by a negative number. Again, multiplication and division are the same as far as sign rules go. Now it reads correctly. We know that 3 is bigger than x, and x is bigger than 0, or 3 is larger than 0. So now it looks correct. So be careful. Make sure you put them in numerical order. So we're going to put the 0 on the left and the 3 on the right. On the 3, because there's an equal to next to it, we know we need a closed circle. And on the 0, there's no equal to, so we're going to use an open one. X is still bigger than 0, which is this way, but it has to be smaller than 3. So we're going to stay right smack between the 2. And finally, we're going to go with the parentheses 0 to 3 with a bracket. So, and that's why you flip or reverse the inequality when you multiply or divide by a negative number. You'll end up most of the time dividing by a negative. Multiplying by a negative is only going to happen when you have those fractions. Now let's do one more example before we tackle some applications. So example 6, we have the quantity x plus 2 times the quantity x minus 3, and that's going to be greater than x minus 1 times x plus 1. So because we have parentheses, we're going to come in and FOIL everything out. So let's go ahead and multiply everything out. When we FOIL this, the first term would be x squared. The outside term is a -3x. That's the x times that -3. The inside term is going to give me 2x. That's this one times this term. And then finally, 2 times that -3 is -6. On the other side, we'll FOIL that one too. So we're going to do x times x. This is x squared. X times 1 is 1x. -1 times x gives me a -x. And the -1 times the +1 gives me -1. Now we're going to clean that up. And some of you may not need to do that step. You can probably do this in your head. So x squared minus x minus 6 is greater than x squared plus x. Sorry, those x's cancel. So -1. Okay, well now we try and move the x squareds to the same side, and they're going to cancel out. which makes it a linear inequality with negative x minus 6 is greater than negative 1. So we're going to go ahead and add the 6 to the other side. That'll give you negative x is greater than a positive 5. And then we're going to come in and divide everything by the negative 1, remembering to flip the inequality. X is greater than, oops, it flipped the inequality. I said it, just didn't do it. So x is less than a negative 5. So on our number line, there's the negative 5. We're going to have an open circle because there's no including the endpoint, and we need to go to the left of that. So our interval is going to go from negative infinity to negative 5 with a parenthesis. The only reason you're really graphing these is to help you get this written correctly. So it's a lot easier to match this to this than it is to go